The idea with these probability distributions, as you've been learning, is that not only can we kind of treat them like functions, like, you know, when we've been integrating on the curves and things like that, but also because they're just like probability and they're very similarly related to statistics, we can actually find these values for a probability distribution, right? So when you think about the mean, you think about the average, right? But in a probability context, like if you're thinking about, you know, flipping a coin, like think about what does the meaning of the average mean? If I'm flipping a coin 100 times, like what does that really mean to find the average? And you kind of talked about this in year 11. Typically for probability, we don't use the term average, but we use this capital E here. Does anyone remember kind of what that's talking about? Expected, right? Because the expected value is similar to the, is a similar calculation to the average, right? And the meaning is the same. So it's basically how many of that particular success would you expect? You need two of those. One of those is answers. And, yeah. Cool. So the expected value. Now I'll show you the proof for the expected value. And the idea is that it relates to basically what your score is and then what's the probability of that score, right? So in year 11, you learned a formula that looked like this. Yeah. So this is basically saying, okay, I want to take the sum of my scores times the probability of those scores, right? And we know in a binomial, in a Bernoulli distribution, there's only two possible scores that can happen. What are those two possible scores in a Bernoulli distribution?
Yes and not yes.
Yes and not yes. So 0 and 1, right? So numerically assigned 0 and 1. So the way that I'm going to lay this out is you can think about this like in a table. So just get used to seeing these in a table, right? And then at the bottom, they usually have the probability that these things can occur, right? And usually we assign 1 to be the probability of P, 0 to be the probability of Q, right? So the idea here is that we can find an expression for the probability of success or the expected number of values, right? So we sum them up. So that's going to be, okay, well, what's my first score? 0 times Q, yep. And then what does this mean? So I take the score and I multiply it by its probability, but then this sigma symbol, do you guys remember what that means, sir? You add, right? You add, and you add, what's the next one? So you take 1 multiplied by P, right? Which doesn't result in anything particular, it just results in P. Why is that? Well, because if you think about it, if you run one of these trials, like how many would you expect? Well, you expect 4 out of 11 successes, but you can't really get an integer value of that, right? But what if you ran this experiment like 11 times? Well, then you expect 4 of them, right? That's the idea behind where this comes from, okay? So that's a Bernoulli distribution. And remember, the distinguishing factor between a Bernoulli distribution and the binomial is that this is just like one instance. This is like if you flip the coin once, what do you kind of expect to happen, right? That's the idea. It's like one instance, one trial, one experiment. The variance, I won't derive that expression for you. It's a little bit, the variance expression is a little bit more involved. But the idea is that instead of writing Q, right, what's another way you could write that probability in terms of P, right? Because you're saying, okay, well, if this is related to probability, I don't want to just introduce a new variable. I want to relate to stuff that I already know, right? You could just say, using your complementary rules, yeah, 1 minus P, yeah, right? So the variance expression, I'll write that down for you, you can jot it down, is going to be this. So P outside of, well, actually it's PQ, but then, you know, how can we write that? We can write it as P outside of 1 minus P. So this one here I won't derive for you. You can have a look at it a bit later yourself if you're interested. But what I am more interested in looking at is how can we use these to answer questions. So there's an example over here. It's going to rub off. So like with advanced, you're going to find that the calculations for these are pretty straightforward. But it's just the concept of grasping, like, what are you actually doing here? Like, what is the significance of this value and this value, right? The expected value is just how many of that success that you would expect, right? So finding the mean and variance, so all you have to do is just substitute in your values. So remember, P is your probability of success. And the variance is going to be like our spread, right? So there's no actual calculations required for this one. It would just be 4 over 11, right? And that would be our expected value as well. Harry, what about our variance? What values am I interested in for that?
Also Q.
Yeah, so what is Q? Or 1 minus P? Well, you've got it over there, right?
Yeah.
So 7 over 11. So the variance, now you just put those together, and that'll give you your answer. So what's that? 28 over 121. Anything else? Simplify any more? Questions about that?